Okay, hi there, welcome to the 7th video on the differentiation topic at higher. Today we're looking at increasing and decreasing functions. So learning intention for today is be able to use differentiation within increasing and decreasing functions, and within that be able to do three things. Being able to use the differential to find if a function is increasing, stationary or decreasing at a given point. Being able to show that a given curve is never decreasing, and being able to find the range in which a curve is either increasing or decreasing. Okay, so firstly, looking at what increasing, decreasing, stationary actually means. Increasing, quite simply, is where your function is going up the way. Okay, so where that tangent has a positive gradient. Okay, so the increasing is going up the way, so the tangent has to be positive, therefore the differential has to be positive. Okay, for stationary, the tangent has a gradient of 0, which means your differential is equal to 0, and then decreasing, the function is going down the way, so its tangent has a negative gradient, so therefore the differential is negative. Okay, so looking at an example, we're able to state whether this function is increasing, decreasing or stationary at x equals 2. Increasing, decreasing, stationary all depends on the gradient, which means it all depends on the differential. Okay, so to get the differential here, we're just going to do exactly the same thing. F dash x is equal to, well, that will be 6x squared minus 3. Okay, when x is 2, I want to know what the differential is, because that will tell me the gradient, which tells me whether it's increasing, decreasing or stationary. So it's 6 times 2 squared minus 3. 2 squared 4 times 6, 24, take away 3 is 21. Okay, so because f dash 2 is greater than 0, f of x has to be going up the way. It's got to have a positive gradient, which means it's increasing when x is 2. Okay, so that's us using our differential to find out what the gradient is, and that will tell us whether things are increasing, decreasing or stationary. Example 2, we want to show that the function f of x is never decreasing. Okay, so that means that f of x has never gone down the way, which means that f dash x can never be negative, because we do not want that gradient being negative. So essentially here, I'm just going to give a wee target. We want to show that f dash x is always greater than or equal to 0, because if the differential is greater than or equal to 0, that means the gradient is always 0 or positive, which means it's always stationary or going up, so it's never decreasing. Okay, so firstly, we know we're going to be working with our derivative, so let's get that. That ends up being 3x squared minus 12x plus 12. And now we have to have a wee think, okay, how am I actually going to make sure that people know that this is always positive or 0? Okay, and numbers that are always positive or 0, our best friends are the square numbers. Okay, because if we can show something's a square number, it has to be positive or 0. And this comes into kind of two areas of the course. A couple of units ago, where we looked at quadratics, we had to show that the roots weren't always real, so the discriminant was always greater than or equal to 0. And here we're doing the same thing but with a derivative, and that means we have to show that this derivative is always a square number, or it is a square thing. Okay, so firstly, we've got a common factor of 3. So 3x squared minus 4x plus 4. And then that trinomial actually is x minus 2 times x minus 2, or x minus 2 all squared. So that is a square thing. So because that's a square thing, it always has to be greater than or equal to 0. Therefore, f of x is never decreasing. Okay, the derivative is never less than 0, so it's never going down the way. Okay, and lastly, just a third example. For what value of x is f of x equals x squared minus x plus 7 decreasing? Okay, so decreasing, that means going down the way, which means f dash x being less than 0. So we want to solve that inequality. So f dash x is equal to 3x squared minus 2x minus 1, and we want to show that's less than 0. Now that there is a quadratic inequality, And to solve quadratic inequalities from the quadratics topic, we know we had to do a quick sketch. So for a bit of working, let's find the roots. So 3x squared minus 2x minus 1 is equal to 0. That gives us 3x and x minus 1 plus 1, which means our roots are negative 1 over 3 and 1. Okay, this is a smiley face, so we're talking about a parabola that looks like that, a minimum turning point, minus 1/3 and 1. If we want to know what is less than 0, well, it's less than 0 all the way around here. Okay, all the way around here. That's where it's below the x-axis. Okay, so our solution to this is our derivative is less than 0 in this region here between minus 1/3 and 1. Okay, so minus 1/3 has to be less than x, which has to be less than 1. Okay, so looking back again at the learning intention success criteria, we want to be able to use differentiate with increasing and decreasing functions. So that would be able to use a differential to find if a function is increasing, stationary or decreasing. That was example 1, looking at showing that the derivative is a certain number, therefore the implication is whether it's increasing, decreasing or stationary. Show that a curve is never decreasing by using square numbers, and find the range of values in which a curve is increasing or decreasing by solving the inequality. Okay, thanks for your time.